Hi guys. So I will first talk about the architecture of credit card fraud detection system using Kafka. First we have simulated transactions of 100 users in a month, which are being stored in a text file and being sent to EC2 client 1. Producer is fed the simulated data and pushes it to the MSK topic 1. MSK topic 1 has been set up as a lambda trigger and it triggers the lambda function whenever new data comes to the card request topic. The lambda function card scrutiny has a business logic where transaction is valid or not on the basis of various parameters, like it checks which category an item belongs to and if in a certain category an item costs more than $100. It categorizes the transaction as fraudulent, otherwise it approves the transactions. Then we have set up an EC2 client machine and it has two topics, approved or denied. Everything is running in VPC and a NAT gateway is configured for the Lambda function to access the data. We have also set up a Kafka REST proxy on the EC2 client machine, which makes it easier for the Lambda function to post data on specific topics. After this flow, a Spark node is fired up on the same EC2 client machine and it does ETL on the approved transactions and denied transactions logs and uploads the resultant CSV file to AWS S3 bucket from where AWS QuickSight picks up the newly created data and generates insights from it. Now I will be forwarding the presentation to Rutvik.
Thanks, Ishan. So I'll go over the short process of how everything works. I'll first show how we have set things up on our AWS account. So this is the MSK cluster. It is of type T3.small, and it has two brokers associated with it, and it is running in a VPC, and the subnets are configured accordingly. Like you have seen in the architecture diagram, there are two EC2 machines running, one which sends or simulates data to the topic card trans request, and the other which receives data from the lambda function and stores them into the topics running on that system. Both the instances are running in the VPC and have the subnets configured accordingly. We have set up the NAT gateway as well, so that the lambda function would be able to stream the data from MSK. So this is the lambda function, which has a trigger set on the MSK cluster on the topic card trans request. Uh, Here is the business logic, where it's just simple logic where we see if the item is in which category, and if it exceeds some certain amount or is below some certain amount, we mark the transaction as invalid, and on the basis of that, we post the transaction to a certain topic, let's say card approved and card denied, on the EC2 client to machine. And this is where the logs would get generated when the data starts flowing into the lambda function, or when the lambda function gets triggered. And as you have seen in the last step of the process, after performing ETL on the approved and denied data, we store the data on Amazon S3, the transform data on Amazon S3 bucket, and these are the files which get picked up by Amazon QuickSight, and we would be able to see beautiful visualizations of the same. So I'll just quickly give a short demo of how everything works. So this is the EC2 client 1 machine, which is simulating the data, simulating the card data. I've just attached the listener so that we would see the card data is getting flowed. So here I'll just run this, and you'd see, okay, the data was sent. Now on the EC2 client 2 machine, the lambda gets triggered and the data starts flowing onto the denied or the approved topic. And here we have set up two listeners, card approved and card denied, which both would store the transactions approved and denied onto their respective files. And so here we would see the logs are now getting generated because the data has started flowing. And I would just stop this proxy right now, and as you can see, it processed 141, 144, 141 messages, and this processed 392 messages. So now the data is in the approved JSON and in the denied JSON. So now I would run my Spark ETL program, which I've written, which will upload the transformed data onto the S3 bucket. So here I would just run that. Yeah, and I'm just waiting for it to finish. Now after it is done, as you can see, the data would then now get uploaded over here, and Amazon QuickSight now picks up the data. And
Hello everyone, this is Likhith here. So I'd like to talk about the JSONs which are generated related to approved and denied transactions as well as the visualization part. So if you can see here, this is the code which we had used here. So basically it's a Spark program which shows about the approved and denied transactions, and also this program we had used in order to perform basic ETL, and then it is helping us to generate the CSV files. So basically it is dumping um, it to directly S3 bucket, which you can see here, and these are the files that are generated using this Spark program. And once these files are generated, I'd like to just show you how it looks like. So these basic CSV files, these are based out of the JSON files which shows about the approved and denied transactions, and it is formatted as follows: the ID followed by the buying place and the item and the amount a particular person is spending. So this is all about the data which we had generated. So that is categorized into three CSVs for our useful insights. The first CSV is df.csv. So that df.csv shows us how a person is spending on based upon the item. So for jacket item, it's almost around 118k is spent upon jacket, and also for lobster 125k, and for shoes being highest, it's almost around 207k. So this is the amount which is being spent there. And whereas df2.csv, which is here, so that shows about items spent by a person. For example, here the ID 51 person is spending around 59k for their monthly billing statement. So this is the monthly billing statement. You can understand about different users spending on different categories and the amount they spent based upon the user. So this is the data which we had collected. And the third one is all about denied count, which shows about which user is having many number of denied transactions. For example, here user ID with 16 is having 8 denied transactions. So this is all about the data which we had generated, and we used these exact CSV files which are internally connected to Amazon QuickSight, which is helping us to build beautiful analysis. So if you can see our analysis, the first analysis is user-based analysis, which shows about the amount the user is spending in total. And this is all about, for example, user 51, which is spending around 59k, as I discussed with the CSV that is just being visualized here, and followed by the other users as well. And the second dashboard which we built upon is based upon the item categories, where 622k being the total amount spent on multiple items, and for the highest being the shoes, it's almost around 207k, which is exactly what we are reading from this data. Shoes, yeah, the shoes data which is being visualized here, and followed by other categories like lobster, blazer, jacket, etc. So this we have chosen donut in order to visualize it better. And the third insight which we built is based upon the amount, which shows about which user is having how many number of denied transactions. For the highest paying user IDs with 10, 19 and 59, with almost denied count around 26, and the user ID with 29 being the least for denied transactions, being only one transaction is being denied for that particular user. So this analysis help us to understand better which user is having more problems regarding denied transactions. So these are the analysis which we did based upon the CSVs which we had generated for different scenarios. this paying for the items, and this paying for the user IDs with the amounts which are spent, and this being for user IDs which they're denied for the count of transactions that were denied for a particular user. So this is all about our project visualization part, and this is how beautiful analysis which is helping us to understand better about the data. So thank you so much for providing this opportunity on behalf of all our team members, and yeah, thank you so much.